Welcome to Subu Medicine, and this is Endocrinology. So today we'll be talking about the adrenal medulla. Okay, that's what we'll be focusing on. So if you look at the structures right here, okay, this is your suprarenal gland or adrenal gland. Okay, but I'll be focusing. I've already discussed about the role of the adrenal cortex, and you guys know that these adrenal cortex are very, very important for synthesizing different types of steroid hormone. For instance, mineralocorticoid, aldosterone, or glucocorticoid, or cortisols, or androgens, okay? But today we'll be focusing on this part, which is the adrenal medulla. That's what we'll be talking about, okay? So, a little bit about this, a little bit of embryology of this adrenal medulla. You know, you guys know this, like this cells derives from for this adrenal cortex, okay? Do you guys know where the cells are deriving from? You probably know, right? For the adrenal cortex, it's going to be your mesodermal mesenchyme. But for this cells here, okay, adrenal medulla, these are neurocrest cells, okay? These are derivatives of neurocrest cells that actually makes this adrenal medulla, okay? That's something that you have to remember. And adrenal medulla, if I just quickly talk about this adrenal medulla, okay, you know, they have those like polyhedral cells, okay? The clusteral cells, they appear to be like polyhedrals, okay? And there are different types of polyhedral cells here, okay? There are some of the cells, they appear to be like a large granules, okay? Large granules, and those large granules, okay, they are the one who are actually important for synthesizing norepinephrine, okay? And because they are large polyhedral cells, they're very, very less in numbers, but there are also other different types of cells, which are smaller, these cells, polyhedral cells, and these are smaller in natures, and they are abundantly present, and these guys are important for synthesizing epinephrine, okay? Because your medulla, okay, it synthesizes about 80% of epinephrine, okay, and 20% of norepinephrine. Okay, so you should remember that. And the cells together, okay, we call these cells, the derivatives of neurocrest cells, we call these chromaffin cells, okay? Or you can call this as a medullary cells. So these cells are called chromaffin cells, okay? And it's because they appear to be in dense granules, okay? We call those granules called chromogranin, okay? That's what we call those granules, all right? Now, after this, you know, let's just talk about the synthesis of the epinephrine and norepinephrine. That's what we'll be discussing about, okay? Now I just drew one cell. I took one cell and I drew here, okay? This is going to be your, let's say, your cell that's going to synthesize your epinephrine, norepinephrine. Remember, guys, norepinephrine, epinephrine, dopamine, these are what? Catecholamines, okay? And we're just going to talk about how synthesis of catecholamines happens, all right? That's what we're going to talk about. And so now, you know, whenever we were talking about synthesizing these catecholamines, okay, these catecholamines, the name itself tells you, these are derived from amino acids, okay? So we need to talk about the amino acids that are actually important for synthesizing the dopamine, norepinephrine, epinephrine, okay? Because together, your epinephrine, norepinephrine, and dopamine, we call them catecholamines, okay? So, how do we synthesize, okay? First, okay, we take from a diet, okay? Look, if you see this GI, right, look at this. We can take from a diet. And what do we take diet? Okay, we can take diet, we can take this basic, the essential amino acids, and that amino acid we take, that is known as, let's write down your phenyl, okay? It's going to be a phenylalanine, okay? This is what we take in your diet, okay? And remember, the phenylalanine is an essential amino acid. Your body does not synthesize phenylalanine, so it's really important that we take this in diet, okay? So now, let's look at this. Let's draw this, okay? But remember, this phenylalanine, you take it here, okay? You take it from the extracellular fluid, okay, and then it gets absorbed in the GI, right? That's what is going to happen. And later, because it's getting absorbed in GI, okay, and then what is going to happen? This later goes to the circulations, and it is going to go and then it's going to take by your liver, okay? This is what it is. This is the liver. The liver is going to take it. Okay, so usually what does phenylalanine looks like? Because phenylalanine is a non-polar amino acids, right? So usually it looks like, okay, let me just quickly draw the structure of phenylalanine. So let me draw it here. So it looks like this, okay? It has this ring structures, okay? This is a 6 ring structures, okay? And it has this double bond into it, all right? And then you have a methyl group coming out here like this, and then you have because it's an H2 group, and then you have a carboxyl end into it like this, okay? And you can label this as 1, 2, 3, 4, 5, and 6. Look, to gather this compound right here, this is called benzene ring, okay? Or aromatic ring, that's what it is, okay? So this is a C6, if you just remember the 6 carbons, okay, let's just write down. This structures, okay, this structures is your benzene ring, okay? This one just has C6 and H6, okay? There are 6 carbons and then 6 hydrogens, all right? So now, this together we call them a benzene ring, and this is the side chains, okay? Now, this together, these compounds, okay, we call them a phenylalanine. And remember, there's amine group, and then this is a carboxyl group, which is a COH, and this is a amine group attached into this, okay? Together, this is called phenylalanine, okay? And this is taken by the liver, okay? When it's taken by the liver, what is going to happen is that it's going to see important enzyme there, okay? And what is that enzyme? We'll talk about that. The enzyme is going to be, okay, from here. Let's say this is taken by the liver right here, okay? This, and then we'll just make it down here, okay? But this is located in the liver, okay, guys? That enzyme is, okay, let's just write it down here. That enzyme is called what? It's called, okay, let me write down here. It's called phenylalanine hydroxylase, okay? So this is going to be phenylalanine hydroxylase because it's going to put a hydroxyl group into this carbon number 4. So let me just quickly draw here, okay? But remember, guys, just think about this is taking place. So let me just actually erase this part, and then we'll make a little bit compound right here, okay? Okay, let's erase this part, okay? And we'll just say, okay, we'll just say this is my blood vessel right here, okay? Now, here what is going to happen is going to important enzymes, okay, in the liver, and it's going to convert. That's called what? Phenylalanine hydroxylase, okay? That's what it is. And look, if we make the structures again, you have this benzene group, okay, and I could just structure like this, and you have like this, an H2 group, and then you have this OH, right? It's exactly the same. So now what is going to happen is that, look, at the carbon number 1, 2, 3, 4, in here it's going to put OH group into it, okay? Like, look, hydroxyl group into it. That's what it's going to do. And because it's enzyme, the phenyl hydroxylase. But remember, this guy is able to do it if there is a presence, okay, of cofactor. Like, for example, there's a cofactor called THF plus O2, okay? That is going to break down into your DHF, okay, plus carbon dioxide, sorry, water. What is that? So this is called tetrahydro, okay, let me write down this. THF is called your tetrahydro, okay, biopterin. Okay, that's what it's got. Okay, this is going to be, so this is like playing as a cofactor for this phenylalanine hydroxylase, okay? That's what's going to, that's what it is. And then really what happens is that this phenylalanine hydroxylase will be able to put a hydroxyl group in the carbon number, position number 4. So when it puts hydroxyl group in the carbon number like 4, then this is no longer as a tyrosine compound. Now this is going to be what? This is going to be, you can call this as, okay, hydroxyl, okay, because it's hydroxyl attaching to it, hydroxyl phenylalanine. You can simply call this hydroxyl phenylalanine, or you can call this as a tyrosine compound. It's the same thing, okay? Now it's a tyrosine compound. Now this tyrosine compound is right what? It's going to complete this circulation. Now if I draw the structures, look, you have this group into it, aromatic ring, right? And then you have a amine group, and then you have a carboxyl, look, and then there is a hydroxyl group into it. Now this compound, okay, this is known as your tyrosine. And which enzyme did that? Phenyl this phenylalanine hydroxylase enzyme, okay, which is present in your liver. Remember, guys, this enzyme is very, very important. In some cases, okay, this phenyl enzyme is deficiency. And if this enzyme is deficiency, what is going to happen is that you're not going to make tyrosine, okay? So in that case, okay, your tyrosine becomes your essential amino acid, which means that you can only get it from the diet. Your body cannot synthesize. And there is, okay, if this enzyme is deficiency, phenylalanine hydroxylase enzyme deficiency, there's a condition called phenylketonuria, okay? And I'm not going to focus into that, but I'm just quickly, okay, letting you know that there is importance of these enzymes, okay? Because there's an important clinical condition related with the deficiency of this enzyme, which is a phenylalanine hydroxylase enzymes, okay? Now, as I said, this tyrosine is not an essential amino acid if there is this phenylalanine hydroxylase enzyme is present. But if this phenylalanine hydroxylase enzyme is not present, then tyrosine becomes your essential amino acid. Okay? Remember this tyrosine is the precursor, okay? It is a precursor to synthesize your dopamine, norepinephrine, and epinephrine, okay? Now, this tyrosine is abundantly present in your extracellular fluid, okay? Now, what is going to happen is that this tyrosine will be taken by the different cells. This tyrosine will be taken by all the cells, okay, that is important for synthesizing your catecholamines. Okay, like for example, your nerve endings in your central nervous system, they will synthesize, okay? And for our case, okay, we're focusing on the adrenal medulla, so these guys will take this tyrosine, okay, into the cells, okay? And these cells are what? Chromaffin cells, okay? So now, when the tyrosines are taken by the cells, okay, and there's special transporter, okay, which is associated with like let's say sodium, okay? And this tyrosine is, let's make this here. There's a pump right here, okay? It's taken here. Now this tyrosine is here, okay? So let me draw this tyrosine structure here. Okay, let me draw this on different. So this tyrosine structure is here. Okay, look. Benzene ring, and then you have okay, let's just write down. That is what it is, okay? And then you have a OH group into this carbonyl positions, okay? Now, after this, what is going to happen? The special enzymes located here, okay? What is this going to do? This is very, very important, okay? What it's going to do is that, okay? It is going to put hydroxyl group into this position, okay? Now, what is the name of the enzyme called? Okay, let's write it down. This is called, okay, let me write it. This is called, because this is a tyrosine compound, we call them a tyrosine, okay, hydroxylase enzymes, okay? This is called tyrosine hydroxylase, or TH. Let me write down full name, okay? It's called tyrosine. It's going to be hydro, okay, oxy. It's going to try hydroxylase, okay? And again, what is required here for this guys to work is you're going to be a cofactor required, which is going to be, you have this DHF. What does that mean? Dihydrobiopentane, okay? Let me write them. It's going to be a dihydro, okay? And then bio plus oxygen, okay? And then it breaks down into THF. Sorry, this is going to be, this is going to be a tetra, okay? It's going to be tetrahydrobiopentane, and then it will break down into this dihydrobiopentane, okay? That's what it's going to be, plus water. Now, this type of hydroxylase enzymes, what is that doing? It is putting a hydroxyl group into this compound. So, let's write down here. Not changing anything, guys. Okay, again, this is a tyrosine compound. You have OH group into it. Okay, and remember, we already have OH here in the fourth position, right? Basically, look, in this compound, here in the, look, this is 1, 2, 3, 4 here, right? 5 and 6. In the 3 position, you'll put a hydroxyl group into it. So when they put a hydroxyl group into the 3 positions, okay, what is that going to become? This is, okay, this is because there is a benzene ring and there's a 2 hydroxyl, okay? Whenever we have the benzene ring and then the 2 hydroxyl there, we call that as a catol, okay? We call them a catechol, that's what we call this, okay? This compound is catechol, okay? And the name for this compound is, okay, we call them a dopa. Okay, what does dopa stand for? Because remember, it is deriving from, it's called dihydroxy because the look, this is a di, because there are two hydroxyl. So dihydroxyl, okay, this is phenylalanine. That's what it's called. Okay, dopa basically means dihydroxyl phenylalanine. And that made this compound called dopa, okay? Now, what is going to happen to this dopa now? What is going to happen to this dopa is they're going to see important enzymes here, okay? That dopa, okay, look, we'll see very important enzyme. And that is what? Basically, what is this enzyme going to do is it will do a decarboxylase reaction, meaning like it will remove this, okay, this carboxyl end, okay? So let's write down in the same compound, okay? There's OH here, you don't want to forget, and OH here, right? And then this reaction, when you're removing the, okay, carboxyl, so you just have NH2 group into it. What we just did is that we removed the carboxyl end, okay? So whenever we remove that, we call the what? We call it as a dopa decarboxylation reactions, okay? Which is basically what it did is that it removed this carboxyl end into it, right? But these guys were able to work whenever, okay, there's a cofactor is required for this. And what is that cofactor that works here? Okay, and that is going to be your PLP. Okay, and it will remove, okay, in the form of this carboxyl carbon dioxide. Okay, what is this PLP is? It's a pyridoxal phosphate, right? It's a B6 vitamin, right? So this PLP is not a cofactor, it's a coenzyme, okay? And what coenzyme does is that it doesn't catalyze the reaction, but it helps enzyme to this, because this dopa decarboxylase is an enzyme, okay? So this guys enhances the enzymatic reactions, okay, for the dopa decarboxylase. That's what it does. So whenever the carboxyl is removed from this dopa, this compound is called dopamine. Okay, now this is dopamine. That's a very, very important now, right? Now this is dopamine. Now, okay, now what is going to happen is that, you know, this dopamine, okay, let's just talk about this is happening here, right? What is going to happen? This dopamine will actually, you know, there's special transporter right here, okay? I'm going to make this 1 granules, okay? Okay, there's a 1 granules here. And this is a large dense granules, okay? So remember one more thing. The synthesis of your norepinephrine, that does not take place in a cytosols, okay? What takes place is on the, because remember I talked about in this medulla, there's those large granules, okay? Those large polyhedral cells, okay? Those large granules, okay? Those large granules have a special transporter right here, okay? That's like a dopamine inside it, okay? And what is this transporter called? We call them, is because it's a vesicle, okay? We can call them a vesicle, okay? MAT, which basically means a vesicle mono amino transporter, which takes dopamine, okay, into this cells, okay? Now dopamine is here. Okay, that's what it is. Now, it's really important because synthesis of norepinephrine is taking place in these large granules, and you have to remember that. So what is going to happen? Look, this compound dopamine, I'm just going to write down dopamine here, okay? Okay, let's just write down. Again, okay, dopamine, carboxyl end into it. There's going to be OH here, okay? And then you have an acid, okay? So this is a dopamine. So with this dopamine, okay, let's just write down here. In this large grain, they're going to see important enzyme, okay? And what is this enzyme does is that it's convert this dopamine into norepinephrine, okay? And how does it do is that, okay? By putting a hydroxyl group into it. That's all it does, okay? And what is this name of the compound we can call? We call this as a, okay, dopamine, because it's a dopamine, okay? So dopamine, and at the beta position, because this is going to be beta alpha, beta hydroxylase enzymes. Okay, so basically at the beta position right here, it puts a hydroxyl group into it. But remember, again, there is a cofactor is required, and here cofactor is given by, you know, vitamin C, guys. Remember vitamin C? The vitamin C. What do you call the vitamin? What is the name of the vitamin? It's called ascorbate, right? Ascorbate. That gives, okay. And then obviously with ascorbate, they require copper too. You don't want to forget that too. So ascorbate is what? This is your vitamin C, right? Ascorbate. That's what it is. And then whenever, okay, because this is a coenzyme, okay? And this is helping the dopamine beta hydroxylase to actually put the hydroxy group in the beta positions, right? That's what does. This vitamin C is very, very important. And whenever we do this, okay, what do we make this? That's something you remember, right? So now, this will break down into what? Dihydroascorbate, right? That's what it's going to become. So it's become dihydro, okay, ascorbate. That's what it's going to become, okay? Now, plus obviously water, right? And you're going to have a oxygen also this. So now this is putting at, okay, now we'll make this, okay, I'll make this a little bigger so that way you know. Okay, what is this? This is going to be, again, aromatic ring here, OH here, right? And remember, 1, 2, 3, NH2 right here, right? Epinephrine. So basically, with this, guys, okay, we're putting what? Hydroxyl group into, this is beta alpha, here, right here. Like this. Now, this compound is your, okay, your norepinephrine. This is, guys. Okay, and this is taking place, or synthesis of norepinephrine is taking place, is on those large granules, okay? So it takes place in there, okay, large dense granules. But then after what is going to happen is that this norepinephrine will leave this cell, like this granules, with obviously transporter with a VMAT, okay? And it will go to the cytosols. Because synthesis of epinephrine will happen in the cytosols. And you have to remember that, okay? So now, this little guy come here. Let's say this is, okay? This guy is norepinephrine, right? So in the cytosol, this is what it is. You have OH and you have OH, right? Now, what is going to happen here is that, okay, there's OH here, and then you have this guy, right? So you have you're going to have alpha, beta, and the NH2. Okay, this is my epinephrine, norepinephrine, right? There's a special enzyme they're going to see there, okay? And what this does is that, okay, it just transfers methyl group into this amine group, okay? So whenever there's a methyl group attached to this amine group, it no longer becomes norepinephrine, it will become epinephrine. And what is that enzyme called? We call these enzymes, okay? This is called, okay, let me write it down here. It's a little longer, okay? These enzymes, okay? Look, quickly. This enzyme is very long. It's called, okay, it's called phenyl, okay, ethanolamine, okay, N, because methyl transferase, or simply called it PNMT. This enzyme is called phenylethanol and methyl transferase because basically in the amine group, it's adding a, methyl. And there are some guys here who helps with helps the transfers of the methyl group, and those are, okay, you have to remember this. This is called S, okay, adenosyl methionine, or simply call this as SAM. And this help because this is going to help to transfer the methyl group into this, and it will become your S-adenosyl, okay, homocysteine, or simply call this as SAH. Okay. Now, what this makes is that, okay, whenever you add methyl group into this amine group, these guys will be called. Look at the structures. It's gonna be OH here, right? And then you have a OH group into here, and then you have this NH right here, right? And you just add CH3 here. Now this compound right here is your epinephrine. Okay, this is your epinephrine structures. Because all we're doing is adding a methyl group into this NH group, and it is your epinephrine. Okay, and this takes place in the cytosols, right? And you guys remember, there's a lot of functions of dopamine and epinephrine and norepinephrine in our circulations, right? So now after that, we start to quickly talk about this, okay? what is the, before we talk about what epinephrine and norepinephrine are doing in different parts of the cells, what are the, let's say, breakdown products of dopamine, okay? Let's just write it down here, because that's what you get to see in the urine, okay? So let me just write down the dopamine here, okay? So usually dopamine, okay, there are special enzymes, okay? I'll just write down two. One is called COMT, another one is called MAO. This basically means it's a catechol, okay? It's a catechol catechol O methyltransferase, or this is called mono amino oxidase enzymes, okay? Whenever this dopamine, whenever this enzyme reacts into this dopamine, okay, they make this product, okay? This product, it's called homovanillic acid, okay? And this is the breakdown products of your dopamine. This is what you get to see in urine, okay? Because kidneys will extrude out and you'll see this, okay? Now let's talk about, our beautiful guys here. We made what? We made norepinephrine, right? Okay, let me write it down where. Okay, let's just write it down here. Same thing. Usually whenever you work with norepinephrine, and we'll make this, epinephrine here too, okay? So whenever norepinephrine, okay, is worked by the COMT, and obviously there's going to be CAM and then CAH, okay, this is helping these guys. You make, okay, these are breakdowns. Whenever this work by COMT, you make a nor, because we're talking about nor, metanephrine, that's what you make, okay? And the same thing with this epinephrine, whenever this guys is also worked by COMT, which is the catechol O methyltransferase, and again you are required SAM with the SAH, okay? You don't make normetanephrine, you make just a metanephrine. That's what you make. And then what happens to the normetanephrine and metanephrine is that this metanephrine can, something else can work this. MAO can use this metanephrine and break down. And same thing in normetanephrine. It can work by the MAO. And you know what it's going to break down into? It's going to break down into VMA. What is this called? This is called, okay, a vanillic mandelic acid. That's what it is going to be, okay? So whenever, okay, MAO works onto this, you're going to make a vanillic mandelic acid, okay? But remember, sometimes, not only, this epinephrine and norepinephrine, this epinephrine can also work, okay, by MAO. If this worked by the MAO, then it doesn't make metanephrine. What it does is that, it will make something else, which is called hydroxy, okay, it's called hydroxy, okay, mandelic acid. That's what it will make. Quickly. So whenever the epinephrine, because look, there are two enzymes. You have a COMT and MAO. If MAO enzymes, okay, monoamine oxide reacts with the epinephrine, then it will break down into hydroxy, okay, mandelic acid, okay? Same thing with this. If the norepinephrine is worked by the same MAO enzymes, it will make hydroxy mandelic acid. Then this hydroxy mandelic acid, okay, that will react by COMT, okay, with obviously require SAM into SAH, and then you make VMA. Okay, that's what it also happens, okay? So, as the level of this enzyme present, okay, so, but the ultimate breakdown product will be VMA, okay? This is what you get to see in the urine, okay? So again, quickly, I'm going to repeat this. If this epinephrine is reacted by this MAO enzyme, okay, that's going to break down into hydroxy mandelic acid. And then hydroxy mandelic acid will be reacted by the COMT, and then that'll make your vinyl mandelic acid. That's what it is going to make, okay? And this is what you get to see in the urine, okay? Now, same thing with the norepinephrine. If the norepinephrine works as COMT, you make normetanephrine, and the normetanephrine can react by MAO to make this guy, which is a VMA, right? Mandelic acid, all right? And this is the breakdowns of the epinephrine and norepinephrine, okay? And dopamine breakdown is going to be your homovanillic acid. Now, let's talk about a couple of things. This guy is right here, okay? This guy, this tyrosine hydroxylase, this is your rate limiting step here, okay? It's a rate limiting step. It is very, very important because these guys will convert, make a dopa, okay? And you need to go through this process in order to make epinephrine, norepinephrine. All right, it's very, very important. This is, so as I said, the tyrosine is a precursor to synthesize your epinephrine, norepinephrine.